I've got a few things. I'm a little behind, and it'll probably.
We are recording. Welcome to our instructor training class, folks, especially our instructor training class for Introduction to Networks. We're going to go back today and look again at our 7 holy steps of subnetting, and also look at, again, remember we're talking about classful subnetting, okay, at this point. I have not yet talked to VLSM. I haven't discussed VLSM, but we're going to, okay, we're going to do that. But I'm back to our same network here that we had, and in this network, we've got to figure out the number of networks we need. And we talked about we need one here, there's one. There's a shared network here because these two have to be on the same subnet or they can't talk to each other. There's a network here and there's a network here. So we're saying that if we look at this diagram, we would say we need 4 networks. And step 1 of the 7 holy steps of subnetting were find the number of subnets that you need. Well, what I'm going to do is I'm going to say that you've got 4 showing up there, but guess what? I want you to use 15 subnets. So, as we go back and look here, we look at this particular screen, go back. I've given you this particular network. This is a class what? Anybody remember what class of address this is?
Class C.
It's a class C, okay? Starts from 192 to 223 would be class C, okay? This is one network of how many hosts? How many host bits are in this network?
Well, host bits is 255.
Okay, and 254
minus 2. Yeah, right. minus
so
2
really,
for network and broadcast.
So it's actually 256 minus 2. Okay, because it's 0 to 255, which is 256 bit positions, because it's 2 to the 8th. But look, we've got this. These are all network bits, right? Because it's a class C, so we know these are network bits. These are the 8 host bits that you have. Remember my formula of 2 to the H minus 2 equals the number of hosts? All right. So if we do this, 2 to the 8 minus 2 equals 254 hosts. So this is one network of 254 hosts. The problem is, by looking at this particular diagram, you know you need at least 4, but even worse, I told you need 15 subnets. So now we're going to have to subnet this thing for 15 subnets. Now, step number 2 is write out your host bits. We've got 8 host bits, right? And down the road, you won't have to do this because it's easier and you can understand not using this. We'll also use VLSM, and I'll show you how easy that is. Step 3 is determine the number of bits you must borrow to get the needed number of hosts. 2 to the n equals the number of subnets. So what power will I have to raise 2 to get at least 15 subnets? 2 to what power? Now, this is where we get this. You remember how I told you about doing this? 2 to the 0 equals 1, 2 to the 1, 2, 2 to the 2 equals 4, 2 to the 3 equals 8, 2 to the 4 equals 16, 2 to the 5 equals 32, 2 to the 6, 64, and 2 to the 7 equals 128. Now that's 8-bit position, so that's really all we need to do for an octet. So what value will I have to raise 2 to get at least 15 subnets?
4.
4. So 2 to the 4th power equals 16. So step 4, we're going to borrow or turn on 4 bits. 1, 2, 3, 4, 5, 6, 7, 8. What's the value there? What does this equal? If you turn on 1 bit and it's all zeros, what is it?
128.
Turn on 2 and all zeros, it's 192. Turn on 3 and all zeros, it's 224. Turn on 4 and it's 240. You also could have added 128 to 64 to 32 to 16, and you would end up with 240. Okay? Now, step 5, take the existing subnet mask, which is 255.25. I'll try to make my 5 look more like 5. 255.240. So that's your new mask for all of your subnets. Okay? And then now step 6 is determine your variable. And when you go to determine your variable, you look at the highest order bit, left or right, and find out what the value is. What's the value right there in that bit position? By the way, here's something I can tell you. It's going to equal this, right? So it's 16 is going to be your variable.
So that's the increment of the addresses every 16 bit?
That is exactly correct. So your variable is 16. So now, in step 7, we can actually start finding our subnets. We know it's going to be 192.168.12.0. Okay, that's where we start, because that's the original network.
Okay.
And then every subnet is going to have increment by the 16. But remember, 0 is a digit, so 0 to 15. And some people do this. They just do 16, 32, 48, and y'all may have to help me with math on these, because I'm a 47. All right, let's see. 16 would be what? 64? Is that right?
Yeah.
Yep.
So 64, 80,
96.
96,
The next one's weird.
112.
Is it 112?
112.
Yep. And then so on and so forth. I'm not going to do all 16. But I can tell you this. The last one's going to be 240 to 255. How do I know that? Does anybody know?
Well, 255, that's your last bit.
Well, and 240 is the
yeah, 240 is your subnet mask. So.
correct, the final mask set. So 240, 255. So there are more in here. And I'm just going to go to 79. So now let me ask you this: how many hosts are on each subnet?
14.
Okay. How'd you get that?
Take away the broadcast in the network, and you got 14 remaining hosts.
Right. And you also, when you look here, how many host bits are left when you borrow 4 bits? 4 bits. So
4 bits.
2 to the h minus 2 equals the number of hosts, remember. And so guess what? 2 to the 4th minus 2 equals 14. All right. Now, here's the thing. I can come over here, and I can put my subnets on this network now, okay? So I can do that. But what's the problem, especially once we get to doing these networks right here? I can put an IP address here, and I can put one here. But what am I doing with these subnets? These are 14 usable IP addresses per subnet. How many do I really need right here?
2.
I need 2. This is a point-to-point link. This is a point-to-point, okay, or P2P. There's only 2 different items here. So what if, instead of using classical subnetting, where every single subnet was the same, what if I could take this subnet right here, this one right here, and what if I could subnet it again? In other words, what if I could borrow more bits than just 4? Now, we borrowed 4 bits, so I want to do this for you real quick. 1, 2, 3, 4, 5, 6, 7, 8. So we know the variable is 16 when we borrow 4 bits. This that we have on the board right here, all of this, these are all subnets using 4 bits being borrowed. So these would be what we call a /28 also. Where do I get that /28 from?
Each one of those ones is a 1 from 24 over. Each
Right.
octet is 1.
Look at your subnet mask. The mask has 8, 16, 24, plus 4, so this is a /28 mask. So any subnet with a /28 mask has on it 14 usable hosts. But I don't need 14 usable hosts right here. That's a waste. I'm going to use 2 of them and leave 12 sitting there doing nothing. So what if, and this is the entire concept around VLSN, what if I can leave all of these other subnets alone? I'm going to use these just as they are. I'm not going to touch them. I'm not going to mess with them. But I'm going to take this first subnet and I'm going to say, you know what? Let's borrow one more bit. In other words, let's go to 1, 2, 3, 4, 5, 6, 7, 8. Now what's my variable? What's the value there? It's 128 here, 64, so I'm going to write out 128, 64, 32, 16, so what is it right here?
8.
It's going to be 8, okay? So I'm going to borrow one more bit, and I'm going to take this top subnet, and I'm going to break it down by the new variable, which would be 0 to 7 and 8 to 15. Now notice, I didn't invent any numbers. I didn't pull any numbers out of thin air. I took this one subnet, 0 to 15, and I borrowed one more bit, and I broke it down. How many hosts are on each subnet now? What's 2 to the 3rd power? 8 minus 2, so there's 6. There's 6 hosts on these subnets, right?
Yeah.
You with me? Well, yep. I don't need 6 hosts. How many hosts do I need?
2.
Oh, I need 2. So guess what? Let's do this. Hey, that was pretty handy. Okay. By the way, at this point right now, we're at a /29. Okay. Let's borrow one more bit. Okay. So let's turn on 1, 2, 3, 4, 5, 6, 7, 8. What's the variable now?
4.
4. So we can take this subnet right here, and it becomes 0 to 3 and 4 to 7. And if we want to, we could take this one and go 8 to 11 and 12 to 15. And now we're at a /30. How many hosts are on each subnet?
Well,
2 usable.
2.
2 usable.
Yeah,
you got 2 host bits. So 2 to the 2 minus 2 equals 2 hosts per subnet. So guess what we can do now? Now we can jump back over here and we can say, hey, you know what? I'm not going to waste all those addresses. This subnet here is going to be, and now let me get rid of this, because we're now no longer doing classical subnetting. This is going to be 192.168.12.0/30. Okay. This will be .1. This will be .2. The only 2 usable IP addresses on it. Over here, oops, sorry about that. Over here on this other side, for this one, I'm going to go 192.168.12.4/30. This will be .5. This will be .6. The only 2 usable on that network. Okay. But down here, I can come back. I can come back and say, no, on these other ones, I'm going to use the following. I'm going to use 192.168.12.16/28. All right. And now I'm back over here. I've got 14 usable hosts per subnet. And then this could be .17. And then over here, I would use 192.168.12.32/28. And this would be .33. Okay. Now, this is variable length subnet masking. Do you see why it's called VLSN?
Yep.
Okay, why is it called VLSN?
You're varying the length of your subnet. You're chopping your networks down into, you're locking your network customers.
Here's what I always tell people. This stuff ain't rocket science, okay? If I can figure it out, anybody can figure it out. VLSN means exactly what I'm saying. you have different subnet masks on the network. What is great about VLSM is we can subnet our IP addresses to match the topology and have the least amount of waste that we can use. Very, very important for our networks. Are there questions before I move on?
Will you go back to the one where you were the third slide? I'm looking at 3 slides across the top. Yes, sir, that one. All right, so my first address would be 12.0 through 12.15.
Well, no, what we did was, as soon as here's one thing that's very important about VLSM. As soon as we borrow an extra bit, anything to the right makes what's to the left no longer usable. So because we borrowed /29 and come up with these 2 subnets, this is no longer usable. Notice too, here's the great thing about VLSM. We use the .0/30 network and the .4, right? That makes this unusable. Yeah. But guess what? If we wanted to, if we decided we actually needed a /29, we haven't used these 2 right here, so we can actually say, well, guess what? We'll just back up and use this. So you can actually pull out this network and use it, pull out this network and use it, as long as they don't overlap. Where you would not be able to do it would be this. Let's imagine that we had that. Okay, so we got 8 and 15, and we went down here and we used 8 to 11, 12 and 15. Okay, so, and we decided, hey, we need to use this one, so we're going to pull it out and use it. Well, now we have to mark this out, because if we try to use this, you would overlap. See how these addresses overlap? So whenever you use a subnet to the right, once you're doing VLSM, the subnets to the left that include those same IP addresses are no longer usable because they overlap. And in fact, if you try to put IP addresses on an interface and they overlap, it will actually tell you it overlaps with another interface. But we can pull and pick pieces however we need them. Let me give you another example. Let's take another example that's going to be based on not necessarily the network topology. It will be, but it's based more on hosts. Okay, I'm going to do something simple. I'm going to do this. Imagine we have this network right here, and I said we need 100 hosts here. We need 60 hosts here. And I didn't tell you anything else. How many hosts are you going to need right here?
2.
How many IP addresses will you need?
You need 2.
2. Yep, so this is 2 hosts. So now it's a little different because you can't do this with standard subnetting, not easily. Actually, you can't even do it with standard subnetting, especially if I give you this address. If I say 192.168, by the way, I'm sticking with this same address. Sorry, but I like this address. Y'all all have your favorite IP address too, don't you? Okay, maybe not. So let's imagine this. Let's imagine we've got this, but we want to build this network. Okay. What happens if I borrow 1 bit? So I'm going to /25. What's my variable if I do /25?
128.
128. So we can break this down to 0, 127, 128 to 255. Now, how many hosts are there per subnet? By the way, this means that you did this. 1, 2, 3, 4, 5, 6, 7, 8. So how many host bits you got left? 7, right?
Yeah, 7. So you've got about what, 124?
Correct. 126, right? Because 2 is the 7th. Is 128?
Oh, yeah, minus 2. Yeah, okay.
So 126.
126.
Now, you're going to need this network because you need a network of 100 hosts. Now, the curriculum teaches this one way. I teach it a very different way. The curriculum would say pull this network out and assign it. I don't like that because typically on our serial links, we try to use .0, .4, .8, .12. Okay? So what I say to do, and the curriculum should say, I think, is we're going to pull this network out right here, and we're going to use it. So down here, this network would be 192.168.12.128/25. What's the first usable IP address on that network?
29.
Okay, so this could be .129. Of course, it's got to have 192.168.12.129/25. Very important that you use /25 because that's 255.255.255.128.
120.
All right. Now, this network's been used. We fulfilled this requirement, the requirement for the bottom network. Now we've got to fulfill the requirements for the top network. Well, thankfully, we still have this top network here. We can go to /26, which means now we've got 1, 2, 3, 4, 5, 6, 7, 8. And I should have done that in black, but I didn't. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, if we do this, what's our variable become? By the way, let me let you in on a little 64. Let me let you in on a little secret. Your variable is always going to be 128, 64, 32, 16, 8, 4. Possibly 2, possibly 1 if you got multiple subnets and like you're not doing a class C. But it's never going to be anything but 1, 2, 4, 8, 16, 32, 64, 128. So it's 64 here. So we can take this subnet and make it 0 to 63, 64 to 127. How many hosts do you have on this subnet?
61.
62.
Or 62. 0. God. Oh my God. I just do what my students did today.
So we're going to do 192.168.64/26 is going to be the network. And we're going to assign right here .65, which is the first usable. What's the last usable in that subnet? So we pull out this sub. Yep. Well, 65 is the first usable. The last usable will be 126.
Oh, I'm sorry. I thought we were still talking about 0 to 63. All right.
No, this network right here. Okay. Now, we have fulfilled the requirements for the top 60 hosts and the bottom 100 hosts. Now we just need, we only need the 2 hosts. There's a couple ways to do this. One way would be this. All right, let's do /27. Okay, our variable then becomes 32, right?
Yep.
0 to 31, 32 to 63, 64, excuse me, brain hard. Then I could go /28. Our variable becomes 16. This becomes 0 to 15 and 16 to 31. I'm not even going to break the other one down because I don't need it. I'm going to come down here and do /29. And the variable becomes 8. And it's going to become 0 to 7, 8 to 15. Now do /30, and this becomes 0 to 3, and 4 to 7. Then I pull out 1. In this case, this one, and it goes right here. And I put .1, and I put .2, and I use 192.168.12.0/30. Now, that's one way you can do it. The other way you can do it is this way. Since you know that you're going all the way to /30, and you also know that you always use the bottom ones, just go here to /30 and go, oh, guess what? It's .0 to 3, .4 to 7, .8 to 11, and then you just pull out what you need and you use it. In this case, we just use one of them, not 2 of them. Okay? So you could use it and just keep breaking it down. But notice, when you're using VLSM, all you're doing is taking the octet and breaking it down by the variable at that position. Each time, that's all you're doing. So VLSM is really not all that difficult. The only time it becomes difficult is when you start having to think about, well, I need 1,000 hosts, so how many host bits do I need? And that is just taking the time to go through it. So, any questions on this before we move to one of those examples?
I don't know, why do we have to learn this? Isn't IPv6 the savior of us all?
Let's put it this way. IPv6, yeah. Yeah, good question. I wish.
Will we ever see it?
Yeah, IPv6, I'll probably long dead and gone. You know, there's a killer asteroid supposed to hit the Earth. It's a 1 in 2,700 chance, which is actually a pretty darn good chance. In 2135, we'll still be using IPv4 when that thing hits and kills us all. So, how about this? I'm going to give you 172.16.0.0/16. And I want you to subnet it for this network. You've got a host, you got down here. You need 500 hosts. Then, I'm just going to make it simple on you. You got another Ethernet here, you need 1,000 hosts. Now, just don't argue with me. I know you never do a subnet with 1,000 hosts, but just work with me. So I'm going to give you a few minutes. I'm actually going to go fill my water bottle up, and I want you to work on this, and I will come back. And we will, I'm going to pause the recording too, so we're not recording nothing. Let me go ahead, I'm going to start recording again. The one thing I'm going to warn you about is this, okay? Typically what you want to do is you want to subnet it first for your biggest number of hosts, okay? So you know you've got to have 2 to the 9th host bits left for this one. So how many do you need for the next one?
10.
2 to the 10, right? Okay. So let's go ahead and look at this, and let's borrow 10 bits. Now, the beauty of this is, get that out of my way. The beauty of this is I can actually go ahead and just borrow 10 bits and turn them on. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So we see now we've got a little bit of an issue because we've got a variable here which is 1 and a variable here which is 64. But honestly, folks, it's not that big a deal. You just take this and you can say, we know we're going to start at 172.16.0.0 because that's our major network number. You know, our variable in the 4th octet is 64. But you cannot roll the 3rd octet until you actually roll the 4th octet completely. So we'll do 172.16.0. what? 63. And 172.16.0.64. The 172.16.0. what? 127, right? 172.16.0.128 to 172.16.0.191. I'm going to slide this over a little bit, or just move this just a little bit. 172.16.0.192 to 172.16.0.255. Now, have I rolled? Oops, sorry. So I've rolled the 4th octet by all possible positions. I'm going from 0 to 255. What's my variable in the 3rd octet? It's 1, right? So once you've rolled the 4th octet by all possible bit positions, you then come back and roll the 3rd octet by the variable.
Okay.
And you'll notice there's a whole bunch of subnets going to be made here, right? Actually, you know what? I did this backwards. I did it backwards.
I'm sorry, I just realized I was like on mute. I've been sitting here talking. Did you want us to like do 1,000 hosts like on a
Sorry, Bob.
22 or?
Ignore what I just said. I have been, okay, folks, that was one of my hit-back moments. You know what that means?
What?
Hit by
That's right.
a truck. Okay? That was a hit-back moment. You've got to have a 10 host bit. So, I apologize. You need 10 host bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which leaves you with 1, 2, 3, 4, 5, 6, right? So our variable is 4. All right, so 172.16.0.0. That doesn't change, by the way. Now we're going to roll our third octet by 4. 172.16. What's our number?
What, through there would be what, 4? Or well, 3. 3, because we got 0.
And then we didn't take anything at all from the fourth octet. So I apologize. That was just a total hit-back moment.
I learned a new acronym. Thank you.
Yep. I hope and pray you never get hit by a truck, but
well, I hope not too.
If you do, you got an excuse. You had a hit-back moment.
Okay. Did I hear you say that you were hit or you were in an accident somehow?
Yeah, I was paralyzed. In fact, in exactly 6 days, it will make 2 years since I was paralyzed completely from the neck down.
Wow.
Yeah, I was hit head-on by a truck while I was cycling at an intersection and paralyzed completely from the neck down. Thank God it was only an incomplete injury. My spinal cord wasn't severed, it was bruised. I still don't feel my feet, and I don't really feel from the chest level down correctly or in my hands, but I can walk and basically take care of myself. So sometimes I have hit-back moments, but it happens.
You obviously can use your hands.
Yeah, I can use my left hand. Thank goodness I'm left-handed. My left hand works very well. Well, not very well. My left hand works, at least works. My right hand is suspect. It can do things on its own sometimes. So my right hand's still got a lot more paralysis. In fact, my entire right side has more paralysis. So, all right. So I apologize for that hit-back moment, but now we have a network right here that has 10 host bits on it. So what is 2 to the 10 minus 2 equal?
1022?
Yep. So this is a subnet of 1,022 hosts, so I can pull it out and use it here. 172.16.4.0 / what would be my slash notation?
22.
Okay, 22. Very good, because you got 8 and 8, 16, 17, 18, 19, 20, 21, 22. So what would the mask be if you wrote it out? It's 255.255. Dot what?
252.
252.
255.252.
Well, it's 255, 255, 255.
I mean, yeah, now look, I'm having a head back. I'm throwing that 252 in the wrong spot.
You were trying to use IPv6 already. All right, so that's the new mask. So the first usable IP address I could put right here would actually be 192, excuse me, golly, I am having a hit that moment. 172.16.4.1 with a mask of 252.0. Okay? Now what we could do is we could take one of these other subnets, okay, and just borrow one additional bit. Because if we did that, if we borrow one additional bit here, okay, what is 2 to the 9th? 2 to the 9th is 512, right?
Yes.
So if we just borrow one more bit, in other words, we go from a /22
to 23
down to a /23, our variable becomes 2, right? So we can break this network right here, this subnet. By the way, there's a lot more subnets here. I just stopped, okay? But I could break that one down to 172.16.8.0 to 172.16. What?
9.
9.255 and 172.16.10.0 and 172.16.11.255. Now I can pull one of these networks out, and that could become the network that goes right here, okay? With a new mask of /23, which would be 255.255.254.0.
That's a common one. We always need 500 hosts.
Yep. Another common one is this.
We all of ours on.
Here's something extremely common. How many bits did I borrow? If you borrow 8 bits from a class B, what do you get?
Borrow 8 bits from a class B. That's a 20. I'm looking at 24.
Right. So in other words, what I had before is I had 172.16.0.0/16. So I had one network of 2 to the 16th host, right?
Yes.
I borrow 8 bits, and I break it into all of these subnets, and each one has the same size as a Class C. Now I have a boatload of Class C addresses that I can use, or equivalent to Class C's in prefix. And then if I need it, guess what? I can still come in here and I can use VLSM and say, we all want this to be 172.16.0.0 to, and I'm just going to do the last octet, this is /30, 0 to .3, .4 to .7. So I can still take these and break them as far down as I need. Now there'll be a whole lot more there. This is VLSM. This is the ability to not have to worry, not look at things from the standpoint of Class A, Class B, Class C, but I am going to break the networks down to whatever I need in order to make it work. Questions? Now, folks, there's a ton of material on this, talking about large broadcast domains and the need to break things down. And then they get into octet boundaries. And this is what I've been teaching you already, because you can see that each one of these, a Class C typically has 254 hosts. A Class B typically has 65,534, and the Class A, a /8, has 16 million and change. So these are very useful. These are useful if you break them down. These are totally useless if you don't break them down for the most part, unless you're just a super, super big organization. Now, here's subnetting on the octet boundary, just like they're talking about. That's all you're going to be able to do is on the octet boundary. So you look at this, they took a class, come on, Pen, do your thing. Okay, there's always another way to do it. They took a class what? What is this 10.0.0? What was this originally?
That's a Class A. Well, actually, a Class B on 16.
Right, but it was originally a Class A, right?
Yeah.
That was a /8. Well, guess what? They borrowed what? They borrowed 8 bits.
8.
When they borrowed 8, if you do that, they just broke it down. Now you can see here how the when you borrow 8. Oops, sorry. When you borrow 8. Aha, found it. When you borrow 8 bits, you've got a variable of 1, okay? So they have to roll all the octets that they didn't borrow anything by. So it's 0 to 255 and 1, and what they did is 254 because they used the usable IP address, okay? So that's the first usable host, the last usable host, and then the actual subnet is this, and then this is the broadcast. But this is neat. This is taking a Class A and making it into the size that you need to fit your network. Here's where they borrowed 16 bits. Look at this. They took a class A, what was a class A, of 16 million hosts. Now they got 65,536 possible subnets of 254 hosts. Much more usable. Now, what we would do is we would actually summarize a block of these to assign to a building, okay? So, for instance, I'll be quite honest with you, on our campus, you can look at the, man, that's aggravating. You can look at the subnets on our campus, and there's 10.x.x.0/ and then typically it's 16. So a building on our campus may be 10.100.0.0/16. That's all the addresses in that building, so you can summarize to it. I'm going to go at Leapfrog, actually, let's be better on Leapfrog. Or Flatfrog, not Leapfrog. So in our networks, like I said, we've got a 10.100.0.0 for the building /16. So for routing purposes that you'll learn more about later, everything can go to one route, which is this set of networks. And then we break this down further to 10.100.0.0 to 10.100.0.255/24, and so on and so forth, so that rooms have certain numbers. So in other words, you know, we've got all of these networks in the building or in buildings. It's not necessarily my building, but you can even do this. Let's say that the room number is 130. You can go ahead and say that the subnet for that room is going to be 10.100.130/24. And then if someone's in there mining cryptocurrency and you're looking in your firewall and you see that it is from a 10.100.130 IP address, you know that is this certain building, this certain classroom, and you can go to that classroom and find out what's going on. So VLSN lets you do some really cool things with your IP addressing. Are there questions? Okay. Everybody's going, oh no, my head's killing me. I'm going to stop this.